Yeah, welcome everybody. I am Mario Torre, and is Marcus here. We are here today to introduce a little bit about mission control file recorder and explain what it is, how it can be useful, and how it can be useful, especially in a production system. Um, that's the agenda for today. As I say, a short introduction, and then we will see one specific use case, but that should be taken as an example of what you can do with the framework, obviously. The example is about open tracing, and we will see how to do analysis of a distributed application with load balancing and everything. The first code drop, I would say a mission control file recorder can be seen as some kind of a framework or a platform. It's actually two big pieces. One is living in the JDK, and that's file recorder. And the other part is a standalone application with a very comprehensive set of APIs that is mission control. Java file recorder was open sourced last year with OpenJDK 11. While mission control was followed practically soon after, sometime in May, I believe, and they both residing as official projects under the OpenJDK umbrella. Since then, it's been less than a year, basically. There's already a very awesome number of contributions. So this has been a very, very good project from the beginning, and I want to take this opportunity to thank Marcus because he's running, it is really, really open on the project. And of course, why Oregon and Red Hat are the main contributor at this point, there's been a lot of discussion and contribution from the rest of the community. So it's a very healthy open source project. So JDK file recorder. The good analogy for that is actually from the name itself. When you think about the file recorder, data recorder in an airplane, is something that starts gathering information of events that happen during the flight. Sometimes also in case of catastrophic events, keeps recording, and then there is a way to store all those events, and then at some point with a forensic tool afterward analyze them. And this is what happens with the mission control and file recorder. Mission control is this forensic tool, while file recorder is the actual data itself. Again, open source in JDK 11 is very actively developed, so the Hotspot team is still adding features at every release. An example of how you can use that. So in addition to the use on metrics, they are there for the actual JVM. There is also a very nice and neat API that you can use to extend your own application. So it's possible to instrument your application, adding events, and then those events will basically use everything that is the same infrastructure that the core file recorder events use, and then they can then be analyzed by mission control. We see here, so it's very easy to add events. This is the most trivial example. It's basically creating a class that needs to extend event, and then you can start adding some information about what it is that you are logging. In this case, the trivial example is just adding labels, but you have all sorts of different metadata that can be useful to analyze and structure the event. Things like the frequency, for instance, or giving meaning to specific fields. And yeah, that is basically everything you do to define those. Then whenever it is necessary, you decide whether the event should be committed. At that point, some magic happens, and then it ends up in the file recorder file. And as you see, this is extremely easy. The next step, the next part of the picture is mission control. Mission control is an application, so it's mostly based on Eclipse. So you run as a standalone desktop application. However, it also has an API that you can use to build your own application using the power of this framework. It's an API, we will see that in the next slide, that is very similar, I would say, to the streams. So you don't actually go and do some one by one event processing on the data. Instead, you ask mission control to give you some statistical analysis for you. And this is very powerful. That's an example, for instance. This is basically a method that is using the API without the full application, but only the API, to create an HTML report out of the rules. So it's basically load the events. This is the event file that's been created by the JVM when dumping the flight recorder file. Another example here, this is a little bit more complex, and by complexity, I really mean just 5 lines of code more. And this explains you how powerful is the whole API. So basically, you're still collecting the events, you're still analyzing them, and there at some point you get a count and average, and those are, as you see, those are basically, you never deal with the single events. You basically ask to the framework to give you an average and the standard deviation, and then you can print the result. In so few lines of code, it's possible to get a lot of information out of it. Some of this information, another example that we were creating some example for this demonstration, and we went for a more complex one that Marcus is going to show you. But as an example you can download. This is very nice because this is basically 2 Java applications running in 2 separate Docker containers. They are talking to each other. One is controlling flight recorder, and the other is actually the VM that is being targeted to be analyzed. And then this is dumping events, the flight recorder data. Then the first application then analyzes using the mission control API. It gives you another use case. Open tracing. On this one, I'll pass.
Right.
Yes.
Okay. Yes. So I actually have a fever, so I might be delirious. We'll see what happens. Anyways, I'm on paracetamol. So open tracing. Yeah. So I have an example here consisting of a few microservices. It's a robot ordering and building application. So these are the 3 microservices. We have an order service that just takes the orders. And when we get an order, we'll verify that the customer is an actual customer in the system. And then we're going to talk to a factory for building the robots. And that's pretty much it. We also have a load generator that we can use to do this full system testing. So this is how it might look. We're getting a request. We're talking to the, say, order system. And the order system, in turn, is going to verify that the customer exists by talking to the customer service. And then we're going to maybe talk to a few factories to start building these robots. But what if something goes wrong? This is where open tracing or distributed tracing systems come in. So Google released a paper called Dapper that many of you probably already know about their infrastructure, their distributed tracing infrastructure in 2010, and that has inspired a host of other systems like Zipkin and Jaeger. How many here knows about Zipkin? It's like almost everybody. So it's a very commonly used tool. Of course, this is nothing new. Distributed tracing is something that people have been doing for quite some time. All the APM vendors are doing this in one way or another. So, and they are all doing pretty much the same thing if we talk about Java land. Everybody's using bytecode instrumentation to get data from various different systems. So the differentiation here is really about what to instrument, what data to get. And then also the other part of the differentiation is really how they present the data to the user. So the value add here is knowing what to actually do with the data once you have it. So previously, if you wanted to add some contextual information, so you have your own application and you would really like to put some pieces of information into this distributed tracing, well, you would need to work with vendor-specific proprietary API. Or if you as a library vendor wanted to add some special information, there again, you pretty much had to work with one of the tracer implementations. So then came open tracing, which is a vendor-independent API, so that you can support multiple tracers with one API. And you can add contextual information without worrying about some vendor lock-in. And There's a spec on GitHub if you're interested in looking at the spec. So I'm quickly just going to go through some basic parts of the API, because you will need to know this when I do the demo. So the core API, well, this is not actually part of the API, but the core concept is a distributed trace. So this is something that will span multiple processes, or can span multiple processes. And it's really a directed acyclic graph of spans. So we'll get to spans. And a span itself has an operation name and some data. So there are key value stores, sort of. It has a start time and an end time. That's really the key piece of information. You want to know how long these spans took, because that's probably one of the key pieces of information you're going to use to find out that something is going bad. Okay, and then there's a span context, and that is propagated across these across the process boundaries. Yeah, so I'm just going to skip ahead. So in our robot shop, this is what this graph could look like. So we have the load generator, which does a full system test. It's going to create a customer, a random customer. Then we're going to post an order, which might be multiple robots that we want to create. We're going to start by validating the customer, then create whatever many robots we want to create, pick up the robot, and fulfill the order, and at the very end, delete our customer. So I'm going to do a quick demo of what this might look like. So I'm going to start bunch of services. You're going to see an exception because I'm running JDK 11 from the scanners. Well, you don't see anything? Well, is this going to help? Do I need to do something else? Or do I need to exit here maybe? Hello. Okay, I'll mirror. Where do I do that? Okay. So, display. Here we go. Okay, so you're seeing something at least. Okay, so I've started a bunch of services, and now I'm going to start a little load generator. Single increment load generator. So it's now creating this customer, and it's going to fulfill an order. And after a little while, we're going to be done there. And I'm just going to start the Jaeger UI so that we can look at our traces here. And here we go. So this is basically the full cycle of us creating a customer. You can see that we first check whatever types the factory can build, and then we're checking what paints are available, and then we create a random user. And at some point here, we're going to start building robots in a factory. What we can see when we start building these robots is that creating a chassis actually there's a lot of variance in how long it takes to create a chassis. So here we're creating an Eve type of robot, then we're painting it red. Here we're creating some other type of robot. And you can see that the variance in how long it takes to actually create those robots. I mean, it would be an amazing factory that can create robots in seconds, but still, it's a lot of variance. And why is that? And this is typically where these distributed tracers break down. You don't get the information that you need to actually be able to do something about this. So you know that there is a problem probably in the factory, but you don't know what to do about it. So what if we Jesus. Okay, so I'm going to just do it like this. So exit here. I don't care. I've got a fever. So here we go. So the idea then is, what happens if you start marrying flight recorder with the distributed tracer? So what if you could get the low-level information that you require to be able to solve these kind of problems, and you can marry that with the tracer? So basically what you would need is some way to take the contextual information that you have from the tracer and push that into the flight recorder so you can start correlating them, right? You would be able to need to record the trace ID, span ID, all these kind of identities that allow you to properly go find what was actually going down. So one way to do that is to create an open tracing tracer and start emitting flight recorder events using that tracer. And there is a concept that I didn't talk about, which is called scope. And that is a thread local activation of a span. So that rhymes very well with the thread local recording of events in flight recorder, right? So what if we could do that? What if we could start recording this contextual information? Then we could probably do something good. So I built a prototype. I've donated it to Open Tracing. There are still some things in Open Tracing that should be fixed to minimize the object allocations, but it works. And it's built as an MR jar, so it will work on Oracle JDK 7 and Open JDK 11 plus. And there is a link towards the end. I think the link might be to my GitHub repo donating it. So, anyways, so I'm going to do a quick demo of what might happen if we get away. Okay, so I'm just going to go ahead and push some more data into the tracer. And the thing is, I am actually running with flight recorder already. So let's take a look at Jaeger UI. Now we should have another trace, right? So what do we want to do now? We want to check out what the factory was actually doing. So let's go back to my Eclipse and let's look at flight recorder. So all these guys actually have a flight recording running, and it's the factory that I'm interested in. Oops. So I'm just going to go ahead and dump that whole recording. So I've dumped the recording, and I've actually done a little special UI here for traces. So we can see that there is a bunch of traces here, low resolution. And we can see that we have one trace that took 1.3 seconds. So maybe look at what was actually going on there. And let's go to the Java application, well, Java threads actually. And I want to see all of them. And I only want to see stuff that was happening in the same thread during the same time. So here we can see what was actually going on here. And I'm going to zoom in a little bit. So we see our thread local activations of the spans. So we can see that there are scope events associated to that span ID, and you would get that ID from Jaeger if you really wanted to home in on a specific one. And you can see that what's happening here is that we're actually blocked on entering a Java monitor here. So we have a synchronization problem here. And well, we can either go look at the actual lock instances here very specifically, and we'll see that it's this monitor and this is the stack trace. So it's this logger that is being used. And this logger is the thing that we're all synchronizing on all these threads, and that's why we have this skew or variance in the time it takes to invoke this problem. So we now have stack traces. We have low-level events like Java monitor enter. It's not just Java monitor enter. We have parks. We have all these this very rich. If you haven't looked at flight recorder, you'll see that there's a very rich set of events. So there's a method profiler, it's an allocation profiling. In this case, it's thread halts. So what is actually going on when we aren't executing? So what halted the thread? And in this case, it was Java monitor enter, and that's why we're not executing. So how are we time-wise?
I think think we have a few minutes for questions as well.
Okay, so I'll just go back to...
5 minutes more.
Okay. So that we can have some questions, I'm going to sum this up. JDK Flight Recorder has been open sourced since JDK 11, so it's something that you can already use. There are even ARM, builds with Flight Recorder working on OpenJDK. So those of you who are doing embedded systems might find that very useful to record sensor data. And I have an example with using laser rangefinders and recording the laser rangefinder information and using mission control to render what we're actually seeing. So that's kind of cool. Its mission control has been open source. I'm sorry it hasn't been released yet. It's process stuff. So it should be released within, I don't know, maybe a couple of weeks. We'll see. Open tracing is open source, has always been. And that's the vendor neutral initiative for doing distributed tracing. And since I'm Oracle, and since I actually said something about the future, this slide
especially regarding the release.
This especially regarding the release, that might change at the sole discretion of Oracle. So here are some resources. So the project for mission control, that's up there. My blog here. So I'm talking about cool things you could do with Flight Recorder, usually. And then my GitHub, if you want to look at some of the examples, or the tracer or whatever. There are also some serviceability examples for the Java serviceability APIs and stuff. Okay, so I'm going to sit down, I think.
Yeah, do you have some question for us?
Yeah.
Questions? I think I have to go around there and then come here.
So I've been doing similar kind of event, sort of like inserting event into my application. And at the moment, I'm actually using something called micrometer from Spring. So how is that metrics sort of event differs from open tracing, or can they actually be basically, I just instrument it once and then basically I'll get all the events?
So what you mean is how this is different from open tracing?
Oh, so, okay. So open tracing is just an API for a vendor-neutral API to push things into the tracers, right? So you can use it with Zipkin, you can use it with Jaeger, you can use it with a lot of different tracers. So the thing you get with open tracing is the ability to just use one API, and then the end user can choose which tracer he wants to use. I'm not sure about Micrometer or how it's implemented. If you're talking about Flight Recorder and stuffing things into Flight Recorder, well, Flight Recorder is a very highly efficient recording engine built into the JVM. So the overhead when you're using Flight Recorder, and there is a ton of cool things we're doing. Like some platforms we're using invariant TSC for timestamping, getting really fast timestamping. It's a binary format. We're using integer compression to make sure that we're not using more memory than we want to, or well, as little as possible. And there is a whole host of cool things we're doing inside of the JVM to just make sure that it's really, really fast. And if you turn off an event and it's on the hot path, you can be pretty sure that it's going to be optimized away. You're not going to see if you disassemble the assembly for the method, you're basically not going to see a trace of anything that has to do with events.
I think also one point important is the knowledge of the knowledge of everything of those events have. Because it's all tied to the runtime of the JVM. So when you are adding some events, there are custom events for your application, you still have some way of contextualize that with the rest of the environment. And that's where the example Marcus did before is important and critical. It's not that open tracing cannot tell you because of some specific reason, but it's only because it doesn't have the knowledge of the runtime it's running on. Where the virtual machine does have this knowledge, so it's easy for you to correlate the various events in the same application, and this is the power of Flight Recorder, I think.
I think another good point. This is a long answer to your question. Now we're going down a rabbit hole. But another good point is that it's built into the JVM, right? So there is certain information that we can get from the JVM. So heap composition, for example, when we garbage collect, we can start gathering data as part of, say the mark phase of the garbage collector. So you don't need to explicitly go say to, now I want to, go through the heap to see what's there. We can piggyback on already existing systems to get the data. So some data we pretty much get for free, just as part of running the program.
Is it something, is it like, can you actually export the metrics periodically into Prometheus and things like that?
Well,
yes, you can.
That is a good question.
I don't think you want to do that.
Well,
but you can. Because the problem with Prometheus is that Prometheus is very much about harvesting the data. You will end up getting one event at a time. So you can absolutely do that with Prometheus, and have some way of telling. So I don't know if you write a simple application and makes reads the file recorder events and then one by one make them available to Prometheus. But I think this will kind of invalidate the point that you have access to all these statistical methods in the first place, and it's all overhead.
So to take an example, just a random example. If you take a flight recording file, which is a binary recording, which has constant pools for the stack traces. I mean, stack traces are literally sets of integers pointing into the constant pool. If you take that thing and you transform it to JSON, that thing is going to blow up by several orders of magnitude. It's like, and then if you take all that data and you try to push it into an event system, that event system is going to be unhappy. So it's better to get the data when you need it. So for example, the example that I did with the tracer. So when you know that there is something suspicious going on, you can leave the flight recorder running because you're not going to see more than, say, 1% of overhead. You can actually have it running all the time. So when you see something that actually is interesting to you from the contextual data that you get from the tracer, that's when you can dump it and look at the data, the detailed data. And as Mario was talking about, you have in Mission Control a bunch of, there is the core API for Mission Control, which is basically a set of bundles that you can use to do automated analysis of flight recordings. So then you can push that through that pipeline if you want to.
Exactly. So this is what I wanted to ask. So the best approach in this case would be to have some kind of in-between application that does the processing using the API, and then output the results to Prometheus if you want to, in some already optimized form. Yeah.
Oh.
Yes, it's over.
It's over.
It's over.
Well, yeah. Thank you.
Thank you.